Replacing null resource safely. Null resource was often used as a control point, not as real infrastructure. The mechanism was simple. Attach triggers or a provisioner, then force Terraform to treat a value change like a replacement event. The outcome was a working pattern, but it depended on the separate null provider and on behavior that was easy to misuse. Terraform data is the cleaner replacement because it is built into Terraform itself and is designed to hold plain values or drive lifecycle replacement logic without adding provider bloat. Terraform data gives Terraform a managed object that can store an input value in state. The mechanism is that Terraform compares the current input value with the prior state value during planning. The outcome is that a plain configuration change becomes something Terraform can reason about as tracked state, instead of an untracked comment in your code. This is the bridge beginners miss. Terraform only reacts to values it can evaluate and compare. The safe upgrade path is to stop thinking of null resource as a fake server and start thinking of Terraform data as a translator. A human change, like var.app version, moving from 1.0 to 1.1, is stored in Terraform data. Then replace triggered by watches that resource address. The mechanism is not magic. Terraform sees that Terraform data.version anchor must be replaced, and then it also replaces the dependent resource. The outcome is deliberate replacement based on a tracked cause, not an accidental destroy caused by hand-edited infrastructure. The lifecycle reference documents replace triggered by as part of the resource lifecycle controls. Some teams use no resource only to run local execute. That pattern still exists, but the host should now be Terraform data. The mechanism is the same. The resource is created, then the provisioner runs. The outcome is a modernized pattern that keeps the execution hook while removing the old dependency on the null provider. HashiCorp also warns that provisioners should be a last resort because Terraform cannot model their side effects predictably. A beginner mistake is trying to put changing expressions directly into a real resource and hoping Terraform will infer replacement intent. That often fails because not every argument forces recreation. The safer mechanism is to isolate the trigger in Terraform data. Then point replace triggered by at that resource. The outcome is clear causality in the plan. One tracked object changes first, and downstream replacement follows for a visible reason. On a submarine, you never confuse the control signal with the machinery it activates. If a sailor treated a status light as the system itself, they would misread risk and act too late. Terraform data should be treated the same way. It is a control signal inside Terraform's state model. The real-world risk appears when engineers pack shell scripts, API calls, and hidden side effects into provisioners and then assume Terraform can fully reason about them. It cannot. The outcome is brittle automation that looks declarative in code, but behaves like an opaque manual runbook during failure. HashiCorp explicitly recommends exhausting better alternatives before using provisioners because Terraform cannot predictably model their behavior.